Welcome everybody to this month's GlogNet meeting. Tonight we're pleased to welcome Chris Miller, who will be speaking to us about adding maps to our Blazor apps using GeoBlazor. First, a little bit about the group. We are the Greater Lansing user group for .NET developers based out of Okemos, Michigan. Our meetings are free and open to the public and held on the third Thursday of every month. The best way to find out more information is to go to our meetup site, meetup.com/glugnet. A few housekeeping items before we get started. We are always looking to have lightning talks before the main presentation. If you or someone you know is interested in doing a 10 to 15 minute talk about something, please let myself or Joe Kunk know, and we will get you scheduled in for a meeting. During tonight's presentation, we want to keep this interactive. If you have any questions, feel free to come off of mute and ask your question. Or if you don't feel comfortable talking, that's understood. There is a chat feature within GoToMeeting that I will be monitoring. You could submit your questions that way. But we do ask, if you are not asking or answering a question, to please remain on mute so everybody else can hear and enjoy the presentation. At the conclusion of tonight's presentation, we will have a survey. The results for this survey are anonymous, and we are looking just to get some feedback on the presentation tonight. All the results get summed up and sent to our speaker so that he can improve his presentation going forward. So we would really appreciate if everyone would fill that out tonight. The sponsors for tonight's meeting: NIS Technologies, who is providing us this go-to session, and the .NET Foundation, who pays the bills for the organization. Our meetups are typically recorded and posted to YouTube by Sam Nasser. A link to his channel as well as a QR code is visible there. That's the best place to find old presentations. Additionally, if you like this sort of thing, here are some other groups you might be interested in. The Cleveland C# VBNet user group, although I think they've changed their name since then, so I may need to update my slide. The Greater Lansing Area for SQL Server, the .NET Study Group, and if you are in the Southfield, Michigan area, there is an in-person only group called mi.net that you might want to check out. And now it's time for our feature presentation.
Welcome everyone. Tonight's session is going to be an introduction to GeoBlazor. GeoBlazor is a third-party Blazor control for working with Esri maps. As I get control of this, there we go. And what's going on with PowerPoint? Why are we not updating? Here we go. All right, I'm Chris Miller. I'm a software architect for Tyler Technologies, working in the K-12 transportation market, which means I do school bus routing software on a team, and I think we're on 50 states and three or four Canadian provinces. My online handle is Another Lab, and you can find me at all the usual places under that. I also blog seldomly at rajapet.com, and most of my code can be found at GitHub/AnotherLab. I am also a Pluralsight author. I'm currently working on a new course called .MAUI Fundamentals. It'll be like a 4 or 5 hour course designed for the person who may be coming from Xamarin.Forms or has never used Xamarin.Forms, but it will get them up to speed on .NET MAUI. So that should be out in February. So what are we here for? We want to create apps for web, mobile, and desktop. Excuse me. We want to use a common code base, or as much as common as possible. And we want to have a map. And that's what makes it a little bit challenging. So, MAUI. Well, MAUI Hybrid Blazor lets you create an application for desktop and mobile using all the same code. You can also use web with it. It's not specifically a MAUI project at that point, but you're getting to share the same code. So you can have all the same Razor pages and all the backend services. It's basically just a different host for it. So Blazor, if you haven't used it, it's web-based rendering, but without the JavaScript framework of the month to get in the way. You'll lay it as HTML and CSS, and the logic is all C#. You can still use JavaScript libraries, but the goal here is to do as much as your code in C# and not lose your mind. So let's talk a little bit about maps. Excuse me. How do we include maps and provide the same experience in each platform? There's so many different platforms, so many different options. With .NET MAUI, basic support for maps was added in .NET 7. It uses the native maps on Android and iOS. So in that way, it's very much like the way Xamarin.Forms did it. Windows desktop apps end up with big maps in a web view because Windows does not have a native map control for desktop, which is weird, but it is what it is. And of course, each one has a different look and they have different capabilities. With the maps in .NET MAUI, there's less support for custom drawing of map features. It was fairly easy to do in Xamarin.Forms. You can still do it in MAUI, but there's a little bit more work and it's still a little funky to work with. So mobile maps in MAUI, if you're using Android, you're obviously getting Google Maps. iOS is going to use Apple Maps. Both provide basic geo APIs. So you have the API functions for taking a lat long and getting the closest town, or taking the closest town and getting the lat long for it, getting your current position. They all do that. They're all pretty straightforward. Windows Maps, Windows Desktop via WinUI does not have a map control. If you use Community Toolkit MAUI Maps, that provides big maps and they're doing as a web view. So in some ways, it's almost a little bit like having it in Blazor because you're now embedding a web view inside your mobile app. So for web maps, there isn't a standard control for a map. Google Maps is probably what you see the most. It's what everyone uses. It's the default map control. Esri is the big player for government agencies. So why Esri? It's more than just a map. You have custom layers, which you can integrate geographic data. It's great for working with census data. A lot of utility companies will be using it to map out all of their stuff, so they know where all their lines are, where all the wiring is, where all the pipes are. It's really good for climate data. There's a lot of data handling functionality in Esri that you wouldn't get with the Apple or the iOS map controls. So here's an example. These are examples from actual websites. This is like a census tract map. Here's one for the water level. Beer versus wine, which I happen to like. I think it's a pretty cool thing. Per capita spending by U.S. county. But these are all Esri maps because you have far greater control over the look and feel than you would than your standard mobile maps. So if you do any work with a government agency, the odds are they have an Esri license. They're the 800-pound gorilla in the local government and federal government space. The full name of the product that's mapped in GeoBlazor is the ArcGIS Maps SDK for JavaScript. So getting back to Blazor, you can use Blazor to provide the same UI for web and MAUI. You have one solution with a web client project that's using Blazor and another project that's using MAUI Hybrid, the Hybrid Blazor client. And all the Blazor stuff is in a shared library. It's mostly the same code. Obviously, there's going to be some things that'll be different for web than for mobile. Mobile has the full ability to do push notification messages. With web, you're doing some sort of push and receive pub sub library for doing that. And there's some few other minor differences. So doing maps with Blazor, pretty straightforward. It's a third-party control. They wrap the Esri map control into a Blazor component. The company was formed by a couple of ex-Esri developers, so they know the product inside and out. Right now, there are two versions. There's a free-to-use open source control that came out roughly a year ago, I believe. Last fall, a paid pro version became available. Anything you can do with the Esri SDK, you can do with GeoBlazor with a small asterisk. It is a new product. It's a moving target for some things. So not all the features may have been implemented. And as we've been using it over the last year, we found there were some pain points, but they were pretty responsive in terms of being able to fix them. The support was very good. Even the open source control, it's all on GitHub. They have an issue tracker. You can put everything in there. They're also using a Discord site, which is really good for getting information almost immediately. If you have a question or look up something that's been done. It is fairly new. Personally, I probably logged a half dozen bugs that were all addressed, but it was a new component, so there were all sorts of little weird issues. A lot of it was edge conditions, things that they didn't test for. But they were fairly responsive and everything was addressed. So GeoBlazor is a leaky abstraction. The map control and associated objects are accessed through Blazor markup and C# code. Under the hood, it's a JavaScript API. So JavaScript and .NET, they have different memory models and life cycles. You want to be careful if there's a certain amount of overhead that goes back and forth between it. So if you can do everything on the C# side and not have to touch the JavaScript side, there's just less stuff to go wrong, and it's usually a little more efficient. So how do you get started? Their homepage is at dymaptic.com/products/GeoBlazor. With the core product, you get the API functionality, you get simple widgets. So widget in GeoBlazor terms is like a control up here on the map for doing zooming in, zooming out, or a compass. That would be a simple widget. You get the community support, which is really good. With Pro, which is kind of in beta, you get complex widgets. So you could build something really complex to display on the map. Premium support, which I guess means that if you have an issue, they're going to address it quicker. Even with the open source one, I found them to be very responsive. So how do we get started completely? Well, it's Esri. You're going to need an Esri developer account to get started, or an Esri license key if you're working for an agency. You can get a free key from developers.arcgis.com/signup, and you just go in and register. Once you register for the account, you go to the dashboard and get an API key for the ArcGIS Maps SDK for JavaScript, and save that key because you'll need that to use the map. If you bring up the map and it's completely blank, it's because you didn't have the API key. And for the bonus round, you can compile it yourself from source code. If you think you fixed a bug, this slide's a little older. You basically want .NET 8. You'll need to have Node.js and PowerShell 7. Excuse me, and you can build it right from scratch. So to actually get started to using it, create a new Blazor app. It could be server, WASM, or in our case, for a demo. Sorry for drinking all this water. I just got over a cold and my throat keeps seizing up on me. Or MAUI Blazor Hybrid. You'll add the Dymaptic GeoBlazor.core package from NuGet. You'll set your authentication. You can embed a key, or typically what you do is you call a web service that will bring the key back so you don't have the key stored in your application. Add the core file references to _layout.cshtml for WASM or index.html. Add the namespaces to imports.razor. Add builder.services.addGeoBlazor to program.cs. And then data map. Before getting the demo, I do want to go over a couple of things I'll be showing. Has anyone ever worked with Polyline encoding and decoding? If you've done anything with maps, with Google Maps, you may have come across this.
No, can't say I have.
It's a lossy algorithm that'll convert coordinates to a string and back again. So if you have, let's say you were doing an app that did delivery runs for drivers for delivering packages, and you were going to show them his route on his phone on the map, you're going to have a whole list of points. If you Polyline encode it to a string, it's much smaller and can be sent over the wire quicker and with less data charges. Google has their documentations here. We'll take a brief look at that later, but it's pretty cool. You can put the points in and it'll go backwards and forwards. it's efficient for sending large sets of coordinates over the wire. Or if you're storing in a database, you don't have to store the individual points or convert them to an object and then serialize it. You can just convert to Polyline and store it as a string. For example, here are 3 points, lat longs, excuse me, 38, 40, 43. If you pass that into the Polyline encoder, you'd get back this really hideous looking string, which is just a little bit shorter than that. It's most effective when you're doing a larger set. So if you had this set of points, this would encode to that. So it's basically the way the encoder works. It takes each point and encodes the differences between the other points. So the more points you have that are closer together, the shorter the polyline will be. And the other thing we're going to be working with is an extent. So an extent is a rectangle. That's what you want the map to be zoomed to. So you have the lower left corner and the upper right corner. So you would define that with lat and long. And Esri has an API call, a JavaScript API call that'll let you manipulate extents. But if you can do it in C# in your code, you're not bouncing back between C# and JavaScript, and it becomes a little more efficient. And I have a little class that we'll look at that works with extents. So at this point, I'm going to jump into my demo. Let me end the slideshow. So I have a sample app. I basically used the .NET template to build a sample application and added GeoBlazor to it. So in our dependencies, we will have, okay, where'd my mouse go? Actually, it's under that. It's under, platforms. And we'll just look at Android quickly. Resources. No. Where was it? Where are the dependencies? Yeah, I was there. Packages. And we see we have the core package for GeoBlazor. Excuse me. In imports Razor, I've added the components, and I think that's all I had to do for that. So I have a basic map page, and let's dig in this. So what we have is a Blazor control called map view. It's going to be preset to a lat and longitude and a zoom, and with a style I can set the height, because once again you're rendering to a web page, and Esri is a little funny. So basically I take the vertical height and take 20 pixels away for the height. Otherwise it just does weird stuff. In our map view, we have a map component. And one of the properties is the ArcGIS default base map. So base map could be what you want to, it could be a street layer, it could be a topographical map, it can be a camera view map, but it's easy to switch in and out. And then you can have multiple layers of graphic layers. So you can overlay different points and you can turn them on and off at a time. And then we have some widgets, like we have a scale bar, a compass, a search, and the base map gallery widget, which will allow us to change the default base map. So for this one example, I've hard-coded the lat and long. I think this one is set to Albany. I've set the base map to the ArcGIS navigation. And then on initialize async, I'm checking to see if we're in dark mode. And if we're in dark mode, I change the base map to navigation night, or I show that. So I'm going to quickly run this. I'm going to run this on Windows. I can run it on other operating systems, but it's pretty much going to look the same. And we watch my machine slowly compile. So this is your standard .NET template. Here's our map page. And I have it set to come up in Albany. So we have our zoom widget, compass widget, and then our base map widget. And if I run this under Android, come on, stop. I'm going to run it on the Windows subsystem for Android. Which is like watching paint dry. While we're waiting for that to load up, I will show what the Polyline encoder looks like. This is basically just a C# class with decode and encode. So decode is just basic math. We're going to take that string, build it back up again. A lot of math here. This will be the only math I'll be doing tonight. And it'll return a list of lat long. Encode will work the same way. And are we still building? We're still building. While that's building, I will bring up the extent class. So that's, oh, here we go. Come on up. The Android emulator built into Windows is now entering the chat.
Chris, have you found like a scale that you needed that polyline, like a certain number of points that made sense? Because I never heard of it before. It's pretty cool.
I came across it by accident, and I was working on an API at work, and it was sending back because we're doing school bus routing. We're direct. Oh, comes up on the other window. Fantastic. Hold on a second here. All right.
No worries.
I found it to be very efficient with smaller, with larger sets of data, because we'd have a school bus run that'd be going like for driving for a half hour, and we're actually collecting, we're getting the data from the bus, so we're actually getting lots and lots of points, and this became very efficient. So I don't know if you've worked with the Windows subsystem for Android. It looks like a Windows app.
I'm doing things like with React Native and using like Mapbox right now.
Yep.
So I'm just kind of like
locked up.
Just thinking about like these things must exist there too. I just never even heard of them, and I'm still learning and everything like that.
Yeah, there's nothing specific about Blazor with this. In fact, I don't know why that thing crashed. But yeah, this is the Polyline is just working with lat longs, and will work with anything that does a map. So
yeah,
you see, this came up, and so now identical code, except we're now running onto Android. Just the weird Android that Windows comes with, because usually you can't resize Android like this. And while it's running, I have a different page. Now we're going to come up in somewhere near Lansing.
Nice.
And I've coded it. So if I press pizza, I picked 4 random pizza places in Lansing. So I threw them on here and then set the extent to lat longs and then made it slightly bigger to show it. And I'll show you that code. But since we were talking about the polyline, this polyline that's hard-coded here, let's bring it. Okay, so we're looking at this polyline right here, which isn't that long. That's all these points.
Very cool.
So if you're working with a map and you're saying, especially anything you're doing, especially if you're doing a mobile device where you want to minimize the amount of data going over, because it's less likely something will happen to it. Plus, it'll be cheaper, it'll be quicker.
No, and because we're working in ag spaces where we don't know what the network connectivity is going to be like, so it's kind of interesting, like you said, about making it smaller. That's pretty cool.
Yeah, because all these points, and it scrolls off here, is that.
Yeah, nice.
But the points were closer together. But when you're doing routing for a vehicle, you're typically going to see points like this. if you're collecting it. If you're plotting out with, if you're doing some sort of algorithm that's plotting it out, it may look more like this. But even with this, to like 10, 15 points, it comes out to that. That's still shorter than trying to serialize and deserialize, sets of doubles.
Are your points in these things like actual stops, or are they more of like things to change the route and like to get the line right?
These ones I created this afternoon using
okay. You just made
the thing,
okay.
and I'll actually show you that page. Where was it?
Yeah, but that's certainly an interesting question, Adam, especially if you're talking about school bus routing. Are we talking turns to get to stops, or are each of these points individual stops in their own right?
We work with two sets. We will calculate the route that a bus will go, including where they need to stop at corners, where they need to stop to pick up students. We also have our own app running on an Android tablet on the bus that's constantly collecting the location. So we can tell the parent where the bus is. So we're going to have a lot more data because we're collecting like every second, every couple seconds. So we have a lot of data.
Sure.
So this is Google's doc on the Polyline encoding format. And they have, where was it? There's an encoding utility. And so we'll just go here. So if I type in Lansing, and now what I can do is, if I click here and say add location, click here, add location. Actually, that's not what I want, put there. And then say, click here, add location. Click here, add location. I'll just do a couple more. That's what that was encoded to.
Yeah, very nice. Yeah, it's just interesting because I really never thought of like lat longs as being big data points, but I can see where like, as you get lots and lots, like if you're seeing this Android tablet connecting all the time.
Yeah, if you're collecting the information, you're going to get a lot.
Yeah, sure.
And and it's nice because if you do it this way, you store it, you get it back. It's lossy, but it's lossy at a precision that's not significant.
Gotcha.
It's like when you save a JPEG image. Yes, that's lossy too, but you don't notice.
But like I probably could store it in lat long in the database if I wanted to, and then convert it for my transmission and stuff too.
Yes, right? And then convert it back. Yeah.
Yep. So, because I'm just thinking about like we might need the precision in my app, like because we're trying to outline a farm really, or a field in a farm, and we want a little bit of precision maybe because we're trying to do sample designs for where they're going to go do soil sampling. Right. But after that, it's more of like just a reference point, just displaying it, and I could see that coding it could make it more efficient for the mobile app, as you're seeing it out.
Yeah, cool. And it works really, it's really efficient. So we'll jump in the code for that one. And let's embiggen this. So what we did is, for this example, I hard coded that string. And then what I set was, where was that button? So to draw run. Where is the code for parse encoded? So basically it's just taking that string, I decode it to these points, which are its encoding, and then I just create a list of points in the data structure that GeoBlazor wants and add it. And then I draw the route. And this is actually a very inefficient way of doing it, because you'll see it drawn very slowly. What you do is you build up a list of points and then you just do add range, and that works. And then to add it to the graphics layer, let's see, draw route is this guy. So we have a new map extent, new route map, and then I just walk through the points. I add them to my extent, which read lat long. And what I'm doing here is, whatever the minimum, just on the fly, I'm calculating the min and max as each point is added to it. No rocket science here. And then to make the extent bigger, I pass in a factor. Take the absolute value of the max minus min and multiply by that factor. On a map area of what we're looking at, that's reasonably accurate. If you were doing something that was like several states wide, it would be wildly inaccurate, which is why I have this line that's hideously inaccurate and make GIS professionals weep. But for our purposes, this is accurate enough. And then I just make it a little bit bigger, create a new Esri extent. So this new extent, this is calling in GeoBlazor, which means this essentially is going to get mapped to a JavaScript call. But my code for working the extent and making it bigger was in the C# side. And then we tell the map view, go to that new extent, and it tries to size up the map portal to what your extent is. To draw the line, just create a list of map path, and then I'm going to convert using those polypaths, which were, where are they? Yep, I'm adding the route map, which is those points. We get a polyline, and then I draw it twice. I still have it. So I draw it on the outside in black and on the inside in white. So it's just a white line with a black stroke. And then I draw the points on top of that. Simple marker symbol. So this is really easy. It's an outline color, inline color. Those are the predefined symbols. You can use your own images. Like we'll draw a little bus at an angle, little school symbol for the school, and then you just add it to the graphics layer. The pizza one was even simpler. I just added a bunch of points, just randomly picked it using Google Maps saying pizza near Lansing, and just picked ones that looked farther out in the map. And then just create the symbol and threw them on the map. The nice thing, this is all C# code, so you get everything from IntelliSense. JavaScript. Unless you're working with TypeScript, JavaScript is the wild west of type checking. With C#, you're getting all the good parts of C#, and it just works.
It looks really intuitive, like really easy. So that's really awesome.
It is real easy to work with. The Esri stuff is great to work with. The nice thing that the GeoBlazor people did was a one-to-one mapping as much as they could of all the JavaScript features of their map.
Good. Any weird things because of that to a C# person?
There were weird things early on because they weren't mapping things correctly. And I mean, in their source code, there's a lot of stuff that they had to do to get the properties going back and forth correctly. And we were finding edge conditions where you would set something and it wouldn't update, or you wouldn't see what you wanted. So I would have all these bugs logged against them, and they just resolved it. And I would just basically take this template, build an app to do the thing that I know would fail, and then submit it as an issue and give them the link to the GitHub and say, here, run this until it works. And they were happy with that because it gave them a way to test it.
Anything you see like with them using something besides Esri? And I know you said the 800-pound gorilla and stuff too, but just
no, they're
open apps or something else. I was curious, or
no, they're former Esri people.
Okay. Their
component is a Blazor wrapper around a JavaScript API. So before we found GeoBlazor, we were looking at doing Mapbox.
Okay.
And And we were looking at, okay, we're going to have to write a Blazor control for Mapbox.
Yep.
And as we were planning to doing that, we were going to make it generic so we could swap out Mapbox to something else. Then we came across this. It was beta. It was a rough beta, but what they did do worked really well.
Yeah.
What I didn't show was how you initialize it, and it's basically builder services add Maui Blazor view. And if you were dumb enough to hard code your API key into the source code, you could. The better way to do it, and I don't have it set up here, is you somewhere where you have whatever your backend service is, you have a service that will supply the API key. So your app requests the API key and sets it.
Yeah. Nice.
But for the purpose of a demo, I hard coded it, and then of course I hit it. Then I'm not sharing my API key. But in terms of initialization,
Pretty easy.
Add GeoBlazor. Not even Blazor review. This is the one. Add GeoBlazor. That's what initializes it. So it's real simple to set up. And then it's just, if you can spell map view and map, you've got half the work done.
Yeah, that is pretty awesome.
Let's see. That's basically it. I do have some links. I can post them up on the screen. Let me get out of this guy. And why did we swap screens? Swap. Come on. There we go. That's better. So the homepage is geoblazor.com. Their documentation is pretty good. Their samples are pretty good. I would highly recommend joining their Discord server. The chief developers are on there. They respond to questions. If you're asking how to do something specifically, because GitHub's great for reporting bugs, it's not so good if you want to ask a question, how do I do X or how do I do Y? And they're pretty good about that. And then the actual SDK is developers@arcgis.com, which is also useful because that will tell you what's available and goes more in depth into what you can do in GeoBlazor. That's basically it. Does anyone have any questions, or they want to see anything else in the code?
I do have questions.
Cool. I like questions.
Yeah. So anyway, this is Joe. I did work for a period of time for the state of Michigan government, as a consultant, and the project I was on was underground chemical contamination. And some of the things that we needed to do, and unfortunately the software that we were looking at didn't necessarily make it easy to do, the vendor software, was, if you have an underground contamination source, you have several things that are really, really important. You need to be able to calculate the distance between 2 points.
Yes.
And you also need to be able to say, okay, based on this distance from the center, what are the points that I would hit? So as a bloom explodes, I want to know what's it going to affect.
Yes, there are SDKs in the ArcGIS SDK has that kind of stuff.
Okay.
Doing the distance is easy. Showing me everything that's inside the radius of that distance, yeah, that's where they come. That's where it's really handy.
Okay.
I'm assuming that's exposed through GeoBlazor. I'm not 100% positive because I haven't had to do that.
Sure. Sure. We wanted to know which buildings, which water wells, whatever ground wells may be next to be, impacted, right?
Yeah. So I'm assuming then that they had a database of those items with the locations. Yeah.
They did.
Yeah.
And that was, I was there as a SQL consultant, and that was my job, was to manage that database that then interfaced into the Esri maps.
Yep. Yeah. I don't know how much is directly exposed through GeoBlazor for that. However, since those are all basically API calls,
Mm-hmm.
you can still call those directly,
Mm-hmm.
and they'll come back with you make the API call for for this area. What's within the it's usually a circle, sometimes it's a polygon. What assets are within this area, and they'll come back with that, and that will depend on how they have their database set up.
Okay. Okay. Well, I just wanted to bring that forward because that was the scenario that I was involved in, and I know that there were some things that made that a little bit of a struggle. And if we could have easily written a web-facing or mobile-facing application that made that easier, that would have been a big win.
Yeah, because once you get the locations of those objects and what those objects are with GeoBlazor, it's ridiculously easy to put them on there.
Okay.
And the cool thing too is right now this one has a single layer. You can define, it's at design time, you have the single layer. You can also create them at runtime. So for the sake of argument, you have this polygon that's defined this area, and there are different types of assets that you want to see within that. You put each type on its own layer, so you can toggle them all on and off again without having to requery.
So this supports multiple layers.
Multiple layers. This has a single layer. There could have been easily a second layer of.
Yeah, because the multi-layers would have definitely been useful. I mean, we could have done above ground versus underground. We could have done underground by 10 feet versus underground by 30 feet.
Yep, and that would work here. And then you have a widget on the map or below the map. That's the thing about if you go the professional version, you can do a complex widget, so you can design something specifically to say, okay, I know I'm going to have these 4 layers, and I'm going to have a special icon for each layer, and then tap the icon to turn it on and off.
Okay.
And that's a lot harder to do with Google Maps, or almost impossible to do with Apple Maps. There, you're just redrawing the whole thing each time.
Right. Very cool.
But yeah, it's we've been using Esri for years and years and years because all the school districts have it. Esri makes it cheap for school districts to have. So it's all our backend software, the stuff that transportation people do. It's a web app. We're not. It's not written for Blazor yet. So we're doing the JavaScript API. So this is nice that now our mobile apps that the parents can see are seeing exactly the same map that our transportation director is seeing.
Cool. Yeah, I can support your statement that this is extremely common in any kind of government agency. I've done quite a bit of government consulting over the years, and I've never seen anything other than Esri when it comes to mapping.
A friend of mine is in charge of the Windows components for Esri. He goes, for better or for worse, we're the 800-pound gorilla in that space. If we don't do it, no one else does it.
Right. So. Right, and I think they've got the critical mass. No other technology could really break into that space unless they were just so overwhelmingly better. And Esri has so many years of experience. I don't know how you could do that.
No, because everyone thinks, oh, they're just doing the maps. No, they have all the services on the back end for doing data analysis. And SQL Server has some GIS capabilities, but not to the extent you can do with Esri.
Right. Oh, yeah, it's black and white versus color.
Yep, pretty much so. Like when we do a school bus routing, our software actually generates school bus routes for a district, and there's so many things that we have to account for that you can't use with off-the-shelf routing stuff. So we can only send school buses down. We can only send a school bus down the street. That's wide enough for a school bus to turn around. So there's some courts you can't take a school bus down. This is kind of a Florida rule. We can't put a bus stop within 1,000 feet of a sexual predator. So we have to have a sexual predator database linked in with the map. And unfortunately in Florida, you really can't swing a dead cat without hitting a sexual predator. So it can make it challenging to do a school bus. We have to make sure that the kids are being picked up on the right side. We do not want elementary school kids. We do not let them cross the road unless there's someone there to do it.
Yeah.
One tragic thing that we found in our field is there's a critical shortage of school bus drivers, and this districts are being forced to hire people with less than competent driving skills. Which is great business for us because we're telling the bus exactly where to go. When they get to the bus stop, we're showing a picture on the screen of what the kid looks like, and they're scanning it with their badge. But it's a rough industry because they can't get enough people to work for them.
Right. Right. I've seen school districts with, an old bus parked in front of the building with a big sign on it saying school bus drivers needed.
Yeah. Oh, yeah. Big time. We work with some of the bigger school bus contractors, and it's crazy. It's just trying to get people. So, there's a couple of big companies, and if they have multiple districts in the area, they'll shuffle their drivers around to meet the need. But that means you have drivers who are not exactly familiar with the bus route or the students.
Or the kids, right?
So we have to make sure when the school bus gets back to the garage, the school bus driver has to walk all the way to the back of the bus to make sure there's no kids sleeping.
Because that has happened, yeah.
It's happened too many times. And so far, the only thing that works reliably is to put a switch on the back of the bus that they have to go and tap. And we record that. And if they don't
to
tap
be sure
it,
that they actually did it.
Brilliant, I think. Yeah, that's a good idea.
But they'll say that they checked every seat and they didn't get up. We have to make sure that they went to the back of the bus.
Wow.
Yeah.
I think they would understand the safety issues, but no.
No, because they just want to get out. It's crazy. There's all sorts of crazy things that they have to do. Each bus driver is supposed to walk around the bus to do a pre-vehicle inspection. And I know there's one company that sells basically just a barcode scanner, and there are barcodes literally on the bus at different corners, and they have to scan them because that's the only way they can be trusted.
So interesting.
Wow.
Yeah, one of the companies that did it tried to cheat, and they basically made QR codes that basically said left front, left back, right front, right back.
Yeah.
So in at bus garage, the buses are all parked next to each other. So the guy gets off the door, scans the code on the side of his bus and the other side of the bus next to him. So we just said, no, you can't. That doesn't work. You have to tag it with the bus number.
Amazing.
That's crazy.
It's hard to make stuff idiot-proof because they keep coming out with better idiots.
Now you gotta take this with a grain of salt. And this is from my 80-something mother. But as I drove by that school bus that had the sign that said, school bus drivers needed, my mom said, well, the reason why they can't get drivers is because parents don't teach kids how to behave anymore.
And that's why they all have cameras.
Yeah.
There's big business in having the cameras on the bus.
Yeah, I'm sure.
To get the kids to behave, yeah.
Yeah. Well, the other thing they do is you get the right system. It provides cameras on the inside, and it puts a camera on the stop arm that comes out.
Okay.
Since it's illegal to pass a bus when the stop arms are out.
Right.
The camera takes a picture of any car passing it, sends it to the local town. The vehicle gets fined, and the company that makes the camera gets a cut of that.
Oh.
So the camera system is free to the school because the camera people are making money on a certain number of people getting ticketed every year.
They're counting on enough idiots to make it profitable.
Yep, pretty much.
Wow.
Cool.
Very interesting. Do you ever do any school bus ride-alongs as part of your job research or testing?
Very, very rarely. We do have people that are on the bus that they'll do training and stuff like that. But on the development side, no, I don't typically have to do it.
Okay.
I don't blame you, but I think it is a great idea to do, like, be in the shoes of some of these things, you know? But,
Yeah, absolutely.
cool.
All right. Stop sharing because that's everything there.
Very cool. Well, thank you very much, Chris. Excellent information.
Oh, thank you.
I dropped a link in the chat for the form to fill out for the presentation evaluation. I will also email that out later as well in case you happen to miss it in the chat. That I'll leave that open for 24 hours and then close it up tomorrow night. And I'll get you a summary of those results, Chris.
Oh, thank you very much.
Thank you very much, everybody. Have a great rest of your evening.
Okay, thank you. Thank you for having me.